Okay, good morning, everyone. My name is Jeff McIntyre. I'm the president of Grand Valley Construction Association, and on behalf of the Waterloo Region Home Builders, Conestoga Heavy Construction Association, Cornerstone Association of Realtors, and Build Urban, along with the Chambers of Commerce and the Waterloo Economic Development Corporation, it's nice to welcome you to this presentation. As everybody on the call knows, back in December, the Region of Waterloo issued a pause on water permits and citing an increased utilization and increased development. And right away, there was an immediate backlash from the industry showing concerns about whether or not this was the right thing to do, and depends on what side of the coin you're at. There's been a lot of debate, there's been a lot of dialogue, and there's been a lot of frustration, a lot of contention. And there's nobody on this call and nobody in this region takes water for granted. And that's one thing that's really important to know, is that we're not just saying use it up, doesn't matter at all costs. It's not that at all. It's in fact the other. It's like we need to understand the math. We need to understand exactly where you're at. What's the methodology that was used to determine the reason for this pause? This presentation was made on April 14th to the Waterloo Region Home Builders, and after that presentation, I talked to Chris, I talked to the staff at the Home Builders, Marie, and said, I think this is something that we should share with everybody. So, Chris, thank you very much for taking the time to make the presentation again. For logistics for everyone, this presentation will be videotaped and it'll be distributed following the presentation. So if you jumped on late or you missed anything, we'll make sure that you get access to this information. What we like about this, it's the same information that was presented on the 14th. It's the same information that is going to be presented, Chris, in a condensed version to Regional Council that was approved last week. I still find it interesting that a few of the councillors voted against having this presentation, but that's here we are. The subject is interesting in the sense, and there's been all kinds of speculation as to what the real issue is here. Do we have a water crisis? Do we have a water capacity issue? Or as Chris so eloquently put it a while ago, and Minister Flack has ultimately repeated, is that we might just have a math issue, and just understanding exactly what's going on. So in the chat, you'll see Chris's bio and his qualifications. I will say things. I will say that his experience as an engineer and as a water exploration company owner for years is incredible, and he brings a scientific and a mathematical lens to this issue. And number two, Chris is also an elected official, so he also brings the political angle and the understanding of what situation our politicians and municipal staff are dealing with on this particular issue. So we're going to, if anyone has a question, we're going to put it in the chat. Mike will be monitoring that if it's simple logistic questions. At the end, if there's an opportunity, Chris, for us to go through and ask the questions. But what we'll try to do is get through the presentation. It's very interesting, as I said before. I followed it, so that's a good sign. And I think a lot of people came out of there with a clearer understanding of exactly what the issue is, if at all that is possible. So with that, I'd like to thank Chris Garretts from Crozier for attending, and I'm going to pass the screen over to you to walk us through your methodology, and ultimately methodology that makes a lot of sense to a lot of people, and ultimately will be presented to the politicians. So Chris, thank you very much. Over to you.
Okay, thank you. Just sharing the screen. Let me know when we're good. Can you see that?
Yep, we're good, Chris.
Okay. Yeah, thanks, Jeff. I'm happy to be here. It's a unfortunate circumstance, but for me, it's a wonderful. It's wonderful to see so much interest in the groundwater and the water sector, because it's something I've been living for a long time, and it's not often that I can get hundreds of people to listen to me talk about any subject, let alone something that I'm very interested in. So we're going to discuss the water crisis today, what's been done so far, what's planned for the future, and some potential solutions. And what we're not going to do is throw anybody under the bus. So we're not saying that we're right and the region is wrong. We're providing some additional education, some context, and some potential solutions that maybe region staff haven't considered. So yeah, I've got a couple degrees in water resource engineering from Guelph, 20 years as a professional engineer, uh, 30 years as a licensed well technician. So about 20 of those years I was actively in well construction testing as a contractor. I'm on 3 provincial source water protection committees. Was involved in both the Ontario Groundwater Association and the Canadian National Groundwater Association. And as Jeff mentioned, since 2014, I've been an elected official in a small municipality in just north of the region. So during my time as a contractor, I worked on a number of municipal water supply projects in the region of Waterloo, included production well construction and testing, which is exactly as it sounds. It's installing new production wells that are connected to the system, with test drilling programs, which would involve multiple holes to identify where the next potential production well could go, and then well rehabilitation projects, which would be taking existing municipal wells and completing some of the regular maintenance activities that are required to ensure that it keeps operating at the target yield. So this figure shows in green the municipal well fields, and I just wanted to go over some of the areas that I've worked in the past. So we've got Elmira well E10, constructed a new production well in Shingletown, did a test well and a production well in St. Agatha, production well in Waterloo North, some work on William Street, a test well on Strange Street, 2 production wells in Foxborough, another test well at Strange Street, and production well on Strange Street, 2 production wells in the Greenbrook well field, 2 production wells in the Mannheim well field, in addition to another production well and some test wells in Mannheim, production well in Mannheim Village, and some test wells in Mannheim Village, production well in Fountain Street, another test drilling program in Mannheim, 2 production wells in Hespeler, 3 production wells in Pine Bush, some work in Clemens Mills, production well on Town Line Road, a test well for the region, but it happened to be in Puslinch, production well in Shades Mill, additional work in Middleton, right there, 3 test wells in Breslau, and then all the one related to the municipal supply. I did a significant amount of work in Elmira related to the water contamination issue, which we'll touch on on a later slide. So with this slide, I just wanted to have 3 takeaways. So if the presentation ended right now, this is what my takeaways would be, so that first off, we need to continue to use the 2015 safety factor in the interim to allow for development to proceed. So that's what we all want: unfreeze, lift the freeze, and allow development to proceed. One of the reports identified a problem being that the Middleton system didn't have the pressure requirements to connect and service the Mannheim service area. So the second recommendation would be to quickly reestablish that connection so that you can count on Middleton as a backup, and that will help alleviate some of the capacity pressures. And the third one would be just to continue work that is planned and ongoing to restore capacity and add new system capacity. So next up, I just wanted to talk about the Waterloo system, because there's a lot of messaging going out from various sources that the region Waterloo water system is one of the most complex systems in the province, country, world. I added that part. It is a very complex system, but the architects and the designers of the system designed it that way. It is complex in that it has a number of wells, a number of interconnection points, and it uses some groundwater and some surface water. So, but that was the idea. So you don't have all your eggs in one basket. You have options. If they've got ASR wells. So they're the aquifer storage wells. They take water from the Grand River when there's capacity. They treat it and inject it into the aquifer to help restore aquifer levels. So that is a pretty unique solution. That is something they're very proud of and should be very proud of. So it is complex, yes, but it's complex by design. And I just wanted to compare the Waterloo system to a number of other systems. So the Waterloo Integrated Urban System has a surface water treatment plant, the ASR wells, which are the storage and recovery wells, approximately 75 production wells, 5 water treatment plants, and about 153 million liters per day is supplied. So when we compare that to York Region, York Region has multiple surface and groundwater sources. So the York water system takes surface water from Lake Ontario, treats and distributes to many municipalities, some of which are blended with groundwater. The Georgina system is a standalone surface system. It takes from Lake Simcoe, and then they have 5 standalone well-based water systems in 5 municipalities and use about 336 million liters per day as of 2022. So a lot of the similar attributes of the region Waterloo system. The added complexity here is there isn't the benefit of a lot of interconnection. You've got standalone well-based systems that if something goes wrong there, they can't cross supply from another system. Georgina is standing all on its own. So it also has a lot of complexities, and it services a much larger population. Similarly, Peel Region has 2 surface water treatment plants coming from Lake Ontario, one for Mississauga, one for Brampton, and it has the 4 groundwater systems, which are Inglewood, Caledon Village, Caledon East, and Cheltenham, that serve 10 municipalities in the town of Caledon for 599 million liters per day. So again, multiple sources. This one doesn't have the mixing of the surface water and the groundwater, but it has standalone systems that aren't interconnected. So there's more complexity there. So just where are we now in the water crisis? Well, in December, the region announced they had a capacity issue. January, they confirmed their findings through a third-party review. February, they approved the side stream treatment for Mannheim water treatment plant, which if you're following on social media, you'll see council had a tour of that, I believe, this week. April 8th, they revoked the Act 1980 Wilmot policy, which is good. It allows them to transfer some additional water from the Shingletown wells to Mannheim. But as of today, development is still frozen and no new capacity has been added to the system, although there's a difference of opinion on that, which we can get into later. So I've identified the current issues as sort of 3 separate interconnected issues. The first is the proposed change in water management philosophy. Second are the infrastructure and operational challenges, and third is the local water level concern. So first, the proposed change in water management philosophy. I use the term proposed because the region of Waterloo adopted their 2015 Water Supply Master Plan, which contained a philosophy on how they're going to apply a safety factor. So at that time, they adopted the required surplus capacity, which said you take your average day demand, you add 20% on top of that, and that's what you're going to consider your demand for design purposes and to figure out what capacity you have. So you've got a 20% buffer added on top of average day demand as your buffer and your safety factor. So this graph shows the 2015 Water Supply Master Plan showing a potential deficit by 2051 if they didn't do anything, if they maintained the existing sources at 193 million liters per day with the 20% buffer added. They identified a number of projects to be implemented from 2015 through 2051 to address that, including 20 million liters a day in capacity restorations, Waterloo North Treatment Plant, and wells to add 6 million liters per day of new capacity, and 2 phases of additional work that would add 24 million liters per day for a total of 50 million liters per day added by 2039, 40, and which would result in a system capacity of 243 million liters by 2051 and an average day demand of 236 million liters per day with the 20% added. So looking at all of that in 25, 26, where we are now, according to this graph and the 2015 Water Supply Master Plan, the total system capacity should be around 213 million liters per day with an average day demand of 192 million liters, which includes the 20% factor. This is from the Agile report. So Agile is the third party that did the review in January. They reviewed the SEMA technical memorandum as part of the water supply strategy, which will be completed in 2027. It shows the measured daily demand in the gray bars and the gray line, the sustainable capacity, which is the solid blue line, and the sustainable capacity after the 20% resiliency factor has been applied. So that's the new factor that has been proposed to be utilized. So the sustainable capacity is what they've determined as representing the long-term capacity that can be provided on a long-term ongoing basis. So it's not to be confused with total system capacity. So to get the sustainable supply capacity, they've taken 21% off of the total system capacity already, based on their interpretation of what actually can be supplied on a long-term basis. Then on top of that, they've taken another 20% off, which was their resiliency factor, which results in a 37% capacity being taken off in this case. So you've got the 21% and then 20% added on, which works out to 37% reduction in what they consider their operational resiliency versus total system capacity. So to summarize and compare 2015 and 2025 forecast, the 2015 Water Supply Master Plan laid out a plan so that there would be no supply deficit until sometime after 2051. As of 2024, there should have been a 13 million liter per day surplus based on the projections. The new proposed resiliency factor approach results in a deficit of 6.1 million liters per day in 2024 and 33.2 million liters per day with applications and growth factored in, which is a difference of 46.2 million liters per day. So just using the two different approaches is a difference of 46.2 million liters per day. The projected demand from 2025 is close to the observed demand, so of 153 million liters per day. System capacity is down 10 million liters per day, or about 5.1%. So when you apply the 20% resiliency factor to system capacity, there is actually 18.3% or 33.1 million liters per day less available in the entire system as there was in 2015. So how can that be? So we need to look at the change in water management philosophy, or the proposed change. So in 2015, the required surplus capacity was simply as stated before, 20% on top of the average day demand. 2015, they identified in the technical memorandum that they should switch to a resiliency factor, which takes 20% off of total system capacity. So the required surplus capacity adds 20% onto the measured day demand. The resiliency factor would take 20% off the top. So it's still 20%, but it's applied in different ways. And as I'll show in the next slide, this difference, which is still 20%, but the way they apply it has significant impacts on the amount that's available. So I'm going to apply the required surplus capacity philosophy and the resiliency factor philosophy to the 2024 demand and capacity numbers, as this is the most current completed published data set. So this is public information. So the demand in 2024 was 153 million liters per day. The total system capacity is 183.7 million liters per day. If we apply the resiliency factor, which is the new proposed methodology, you take 20% off of that, the 183.7 system capacity. So you end up with a system capacity of 146.9 million liters. Your demand's 153 million liters per day. So you end up with a deficit of 6.1 million liters per day, which is how the whole development freeze was triggered. There, council was told we have a deficit on a daily basis of 6 million liters. The approved method of calculating the reserve, which was adopted in 2015 Water Supply Master Plan, is you take the demand number, so 153 million liters per day, and you add 20%. Your system capacity is still 183.7. Your demand, which is the 153 with 20% added, is 183.6 million liters per day. You end up with a surplus that's pretty much negligible. So you're pretty much at zero. Not a great situation, but it shouldn't trigger a freeze. So what this typically would trigger is the start of the planning process to add more capacity. And this is what we're suggesting, is that the region just simply go down the route that they have been using since at least 2015. So what is the correct approach? Well, there's no real consistent approach. Municipalities use a variety of triggers and values based on their systems. This is the table that was included in the Agile report that compared other municipal targets. It's nice for illustrative purposes, but there are a number here that are 100% lake-based systems, so it's not really reasonable to compare, for example, the city of Ottawa, which has one or two intakes into the Ottawa River, and they have the benefit of sort of having to only deal with that one piece of infrastructure. So they have a very high redundancy and resiliency factor. So excluding the 100% lake-based systems, we're left with the city of Guelph, which uses 15%. Region of Peel uses 10%. So when they get to 90% of the rated capacity, that's when they start the process. City of Brantford starts planning when they get to 20% of the total system capacity, and construction's triggered at 10% when there's 10% left. So none of them identify freeze development as a target or a trigger. Typical practice, as stated, is to start planning when you reach 80% of total system capacity, and start construction when you reach 90% of capacity. So with those 2024 numbers that I presented previously, demand is about 83.3% of capacity. So if you were using a similar approach, this is the time that you would start planning to add capacity to your system. So who is right? Well, the Ministry of the Environment policy or guideline, sorry, not a policy, states that allocated system capacity should not exceed design capacity of the sewage or water system. So it's a pretty low bar, similar to the building code, which is minimum requirements for building. You can exceed it if you want. It's very similar here. They're just saying at a minimum, don't give out more water than you can provide on a daily basis. So it's well within the powers of any municipality or council to set a higher standard. Not suggesting the 20% resiliency factor is not a great thing to strive for. It probably is better than the 20% RSC, but the implementation needs to be allowed to be staged in. You can't make that that fundamental shift overnight, and as a result, stop all development. It's just not feasible. So the second is infrastructure and operational challenges. This is going to be a little brief because it's not necessarily my wheelhouse to work on horizontal infrastructure, but I will just touch on some of the challenges. So the 2015 Water Supply Master Plan identified a lot of constraints and many that were holdovers from 2007. There was a need to increase groundwater supply and a suggestion to update the Water Supply Master Plan on a 5-year cycle. Uh, I think that's a good idea, the 5-year cycle, to update the Water Supply Master Plan. But previously, there was 8 years between their 2007 and 2015 master plan, and we're probably going to be about 13 years in total between the 2015 plan and when the next one is adopted. So I don't know that 5 is achievable or even really required, but I would agree that 13 years is far too long, because that's the document that sort of identifies big picture what you need to add to the system so that you're maintaining capacity. The 2015 Water Supply Master Plan recommended 16 projects related to known constraints in the system, 13 recommended for implementation prior to 2031, 2 after 2031, and 1 with no timeline. So the 2015 Water Supply Master Plan identified the mixing of the water sources with different secondary disinfection methods as an issue. So it was identified and known back then. It's a key part of the 2025 report, indicating that it was not possible to supplement the Mannheim system from the Middleton system, in part due to these differences in secondary disinfection methods. Also, going back to my explanation of the York system, there are large municipalities in the York system, such as Newmarket, that are serviced with a blend of surface water and groundwater, mixing with different secondary disinfection methods. So it's not impossible. I can say it's not ideal, but there is an engineering solution to solve that. The similar as the pressure differential, there's an engineering solution to overcome that. It is unclear to us how many of the projects have been completed. We've requested that information numerous times, and it has not been provided to us. So I'm not sure which of the 13 or 16 projects from 2015 have actually been completed. The next recommendation from the 2015 Water Supply Master Plan was to increase groundwater supply capacity to maintain the 20% RSC. To do that, the region was going to drill new wells to create new treatment facilities. 3 water treatment plant locations were reviewed and decided to proceed with 2. The second recommendation was to drill new wells and restore capacity at 1 existing treatment facility. It was suggested the region would restore existing wells and create additional new treatment facilities, and all of this work was going to add 50 million liters per day of capacity between 2015 and the 2039-2040 timeframe. So, as indicated in the earlier slide, this would result in a capacity today of 213 million liters per day, where we currently have 183.7 million liters per day. So we should have a large surplus at this point in time if the recommendations from the 2015 Water Supply Master Plan were acted upon. So the final issue is the local water level concern, which is probably, in my opinion, the most problematic because it's a more widespread problem in the Mannheim area. So council has heard from staff that the water levels in some of the wells are reaching a point where they could start losing water supply wells. This is partly due to the fact that they have been operating what they call peaking conditions since about 2019. So what they consider peaking conditions are the maximum permitted rates, which they don't believe are sustainable rates. They shouldn't be operated at those rates on a long-term basis. They've been in that situation since 2019. It's my understanding that the concern is around the Mannheim water treatment plant wells and possibly as far as the Mannheim Village wells. So sort of the area that I've circled in red there. So I just wanted to touch on what it means to lose a well. It's the term that they've been using. And to do that, we need to look at how the wells in that area are constructed. So the wells are overburden wells, which means they get their water from the sand and gravel located somewhere below ground surface. the wells are constructed with a well casing that extends into the aquifer, and then a stainless steel well screen is installed. The well screens look simple. It's just it's just looks like a screen. It's horizontal slats and vertical supports, but they are actually designed and engineered specifically to retain a certain amount of material in the aquifer and allow fine grain materials to pass, so that you're allowing those pathways for the water to enter. As we see here, this is a well screen, and you see that there's areas where the coarse material remains. Those are the pathways for the water to enter into the well. The finer grain materials, so the lighter brown, has been removed, so drawn into the well and removed as part of the well development process. So it's important because the pump is usually installed above the well screen. Pumps can be anywhere from 1.8 to 3 meters long. Usually have a minimum submergence from the manufacturer of up to 3 meters. So the water level can usually only be drawn down to about 6 meters from the top of the well screen. So it's possible to install a pump in the well, but there are risks. So you can have the increase in entrance velocity, which is not good for the well. It can draw material in. And the screen can actually collapse due to the suction from the pump. And also, if you have the pump in the screen, there will be a point where you'll draw the water level down close to the top of the screen or into the top of the screen. That allows that adjacent material to depressurize. And when that happens, so when in the previous slide, when I showed the sand that's sort of held at distance from the screen, if you drop the pressure in the well low enough, that depressurizes the aquifer immediately around the well and allows that sand to very quickly enter the well, and it'll fill that screen up immediately. And so you're in a situation there where you have to rehabilitate the well, or sometimes it could just be a total loss. It can be filled with sand. It can lock the pump in there and make it impossible to remove. So that's the reason we don't want to move, decrease the water levels further in those Mannheim wells. So we'll go over some solutions of how we can address the valid concerns that the region has while allowing some development to proceed. So the first solution is always my favorite because it's easy. So it's do nothing. It's always an option, and it should be addressed in every analysis as a baseline. So what would it look like here? You would maintain operations and allocation as possible, continue along the 10-year capital plan. You would allow development to proceed. And if you are seeing issues arise, the region does have tools to reduce demand, such as a lawn watering ban, voluntary reduction from some of your non-residential users. There are a number of solutions there. Not a great solution, but it is an option that is available to the region. So the region has identified a number of solutions on their website. So they include, in 2026, focusing on repairs to existing infrastructure, but there's no new net water capacity. 26, 27 focus on operational improvements at the Greenbrook and side stream treatment at Mannheim, which will add up to 364 liters per second of new water capacity. And we'll discuss that in a second. Then 29 to 32 focus on repairs to infrastructure and add up to 277 liters per second in new water capacity. And I just like to point out that being a little catty here, but I don't know what they're doing in 2028. I think they've taken a break there because there's nothing identified. But with respect to my concerns with these solutions, first of all, many are already in the region's 10-year capital plan. So I don't know that there's a lot of additional solutions being discussed here. These are all things that have already been identified. In some cases, they're accelerating the pace at which they implement them. Some other concerns: 364 liters per second of new capacity in 2026, 27 is through restoration of capacity that's been lost from the Mannheim water treatment plant. So not really new capacity. And I've had discussions with region staff on this. We have a difference of opinion on that. You know, I wouldn't really consider capacity that has been restored as new capacity. I think their opinion is that it is new capacity because it's a side stream treatment. It's a new process in the Mannheim treatment plant. But I think realistically, until we're at a point where we are up and exceeding the capacity that at a minimum we were at in 2015, we really shouldn't consider anything to be new capacity. And many of the projects, as I said, are already in the 10-year capital plan. So I don't know that there's been a lot of identification of new unique solutions. And really the biggest thing is there's little to no tools there to address the development freeze, and many are in the 2 to 5 year time frame, anywhere out to 2027 to 2032. So there's not a lot of ideas on how we can get this development freeze lifted, now. So some other solutions would be that I've just considered or reviewing all programs completed in the last 10 to 20 years. Are there existing test wells or production wells that are available? Is there a case to connect wells in 2026 where it wasn't previously desirable? In 20 years ago, the region wouldn't really consider wells in the 7.5 to 10 liter per second range. Those weren't of interest to them. Right now, the situation is much different, and they've indicated that would be desirable. So they've also assured me that they've reviewed it and there's no viable wells or locations left unused. So the following sections, I just wanted to highlight a couple that I'm aware of, not to say that they're wrong, not to say that they would fix the solution immediately, just to highlight that there may be some out there that the current staff are not aware of. So in Breslau, in the area off Victoria Street North and Fountain Street, we constructed 2 wells in 2005. They were subsequently abandoned after testing. The first one tested at theoretical capacity of 15 to 30 liters per second, so 1.4 to 2.8 million liters per day. The second, slightly less, but they were not advanced because the scope of that project was to identify locations for future expansions. They weren't needed at the time. Another example is a large production well constructed in 2006 at the Portuguese Club of Cambridge, 12-inch diameter production well in the bedrock aquifer, rated for 5.4 million liters per day. And it's currently still there. It's sitting there. It's unused. I'm not sure if staff are aware, if there's been any assessment of that. We did this at the same time that we did a well just south of there on Cedar Brook Court. That well was connected to the water system. The well at the Portuguese Club at that time was not connected. Oh, sorry, there's the well location there. Did some test well drilling in Zowski Park in the overburden aquifer. So this is part of the Strange Street well field. The corner of Westmount Road West and Chopin Drive, constructed in 2011 in the overburden aquifer. Preliminary results indicated it would be around 7.5 liters per second. And again, that test well was not converted to a production well, and it hasn't been used. So those are just to highlight some opportunities. Not necessarily that they should act upon those ones, but to do a bit of a deeper dive into everything that's been done over the past 20 years to see if there are other similar locations that are easy to develop. So the next potential solution is to the low water level concern around the Mannheim system. And one suggestion would be to establish more sources to inject water back into the local aquifer through the ASR wells while maintaining the pumping at the Mannheim wells. So the wells would be established outside of the low water area concern. Water would be piped to the Mannheim system and injected into the ASR wells to address the low water threat. It's a potentially rapid response um, to help address the low water threat. There's some question through source water protection as to whether or not those wells would be required to go through the source protection plan process. I'm of the opinion that they're not. Source protection is to protect municipal water supply wells. These wells wouldn't be supplying municipal water. They would be transferring water from one area in the aquifer to another area and injecting back into it. So I've had high-level discussions with the Ministry of the Environment, uh, and they were interested. They weren't able to offer an opinion as to whether or not source protection would be required. So a couple areas that are possible would be additional wells in Shingletown and St. Agatha, as they already have infrastructure to connect the Mannheim system. So St. Agatha and Shingletown. So if we look at St. Agatha and Shingletown, a large diameter test production well was constructed. We constructed that in 2010 in the overburden aquifer with a recommended pumping rate of 9.5 liters per second. So that's one area. It was never connected to the municipal system. And that's, a potential area where if the well is still there, there's infrastructure pipeline available to pipe the water to the Mannheim area, and you could potentially have some water to inject back into the aquifer. Shingletown, there's 3 wells located here, which are K50, K51, K52, potential to produce over 150 liters per second in the overburden aquifer. It's outside of the urban area, and there's lots of potential in the outlying areas around this Shingletown well field to put in additional supplies. There's the water main right along the road there that goes to the Mannheim system. So you have infrastructure, you have an aquifer with what appears to be ample supply. So that is another solution. And with the revocation of the Wilmot water policy, that is doable. Just wanted to highlight as well that I'm not recommending that as a potential long-term solution. If you're doing this, it is to help the low water condition in the Mannheim wells in the near term, while other work is being done to address it in the long term. So it's not a permanent solution. Doing that on long term could lead to some low water issues in other areas, but if you were able to do that over the next couple of years, it would help with the overall system pressures. Another one would be, and I'm going a little outside the box here, is to assess that the Elmira aquifer. So there's been no water pump from Elmira since 1989 due to contamination. It was originally anticipated that the water would be remediated sometime around 2028. I believe that's when the remediation order is done, and they may need to reassess. But there's been some rumblings that with advancements in treatment technology, there may be an opportunity to meet that 2028 timeline. Waterloo has a well E10, which is connected to the Waterloo system south of Elmira. It's not currently being pumped. It's capable of producing, I believe, 75 liters per second. And I feel like there should be some exploration around whether or not it is time to resume using the E10 well. It's also a former Elmira well located here at 15 liters per second. This well is currently used on an ongoing basis for pumping and treating. So they pump the water, it's treated and injected back into the aquifer as part of the remediation process. And then there's been a number of pump and treat wells that have been installed over the years to to help with the plume. So we constructed these wells in 2014 to supplement wells that we constructed in the mid to late 90s. Each of these wells sort of can produce in excess of 10 liters per second. So there is opportunity there. I think that it's worth discussing, especially the well E10. Initially, it was no longer used because there was concern that that using that well would draw the contaminant plume closer to the Waterloo system. It's a valid concern, but with the positive situation that we're in now with the remediation efforts, I think there's opportunity to start using that well at some rate and monitor in the area and see if there's changes to the plume, and if there are changes and it starts to be drawn towards the E10 well, then that can be a trigger to reduce that flow or remove it. So again, it results indicate there could be a well field of approach there with a number of wells installed producing 10 to 15 liters per second. One other near-term solution, which involves twinning the wells, so it's constructing identical wells beside each other, so that if there is an issue, a mechanical issue with one well, you can use the other well, so you don't have a loss in capacity overall from the system. P10A and P10B in Cambridge are a good example. Two wells located less than 5 meters apart on the same site. The advantages here is that it may not require a Section 34 amendment, which is the source water protection study. Typically, wells in close proximity to each other that are not increasing the overall system capacity. So a backup well in this case doesn't require that study, which can take 18 to 24 months. Disadvantage is it might not add more capacity overall because treatment would still be the constraint, but it would give some level of comfort and redundancy overall within the system. So other solutions is to increase well exploration. So the region of Waterloo is 20 years ago, they had a very robust and aggressive drilling program where on an annual basis, they were doing a number of exploration uh, projects. It should be revisited with a focus on locations in the fringes of the current limit of development. And there's an opportunity to work with the development community to identify lands that might be available for testing. So one of the big delays on the municipal procurement side is, first of all, the tendering process. Second of all, negotiating land access for drilling. So if you have somebody in the development community that would be a willing host, my suggestion to the region was you allow that developer to use a contractor that the region is comfortable with, use the region of Waterloo's typical scope for test drilling. There can be communication between the developer and the region, but allow that to be developer driven. Development community can make things happen a lot faster. There would be a conversation, obviously, of how those costs would be shared, but operate that through the private sector. Crozier does a lot of developer-driven infrastructure projects for that reason. Municipalities, especially smaller ones, prefer it. It's less work for them. They get input, and at the end of the project, they take over that infrastructure. So I think that's another solution. So what do we do now? I think the first is to advocate for council to continue using the 2015 calculation from the Water Supply Master Plan for reserve supply capacity, allow development to proceed, and if they want to change the water management philosophy, they need to phase it in over a reasonable amount of time. I think they need to look at innovative and outside the box solutions. Artificial recharge wells, as I mentioned, could be possible. A complete comprehensive review of any unused test wells and test production wells, and possibly even ones that have been taken offline in the past. And then a review of the Elmira aquifer system, then continue test drilling programs and exploration from long-term sources, and really ensure that recommendations from previous master plans are acted upon. So with that, I think that wraps up the rapid fire presentation. So just ask if there's any questions.
Chris, thanks so much. You're a very gracious subject matter expert. I don't know if it kind of points back to maybe neglect, maybe leadership. And I mean, on behalf of the Grand Valley Construction Association, other associations, we're taking a scientific approach, no question about it, but we also have a bit of maybe a little bit more finger pointing than you do. So good for you for keeping it at that level. One question is, with the math that you've created, is that based on public information, or is there information that the region that you don't have to make that that report even more fulsome? Or what's the do you have enough information to be confident with that? And is there anything that the region is withholding?
I would say that I'm comfortable with the information that so it's the 2024 data. At this point, 2025 could probably be found. I would venture to say there hasn't been a huge difference in the average day demand from 2024 to 2025. So I'm comfortable with that. On that side of things, I don't think the region has been withholding anything. I think our difference of opinion is how they and I perceive what the total system capacity is. So I take the total system capacity as the permitted rates of all the wells. As I mentioned in that one, they take that total system capacity, and they consider, at times they consider a reduction of the total, maximum capacity to allow for what they consider to be sustainable capacity. So we have a difference of opinion there. I don't think either of us is right or wrong. It's just how you look at the system. But so hard data, I don't think we've been lacking. It's some of the questions that we've had around what has been done in the past, what hasn't been done, why hasn't it been done. And again, it's not to point fingers and say you've dropped the ball on this. There may be reasons that some of those projects from 2015 weren't advanced that are valid reasons. So those are the types of things, and the extent of the low water level response around the Mannheim area, that would be good to know. We sort of had to make a guess because that information wasn't provided. But in terms of the numbers and the hard math, I think those are I'm satisfied with those.
Well, that's encouraging. Thank you. A lot of good feedback here. One question is, and I don't know if you can answer this. If not, we defer this back to the region. Does any of the capacity forecasts include the new industrial site that's being put forward in Wilmot? Would that have been included in their calculations?
I'm going to go out on a limb and say it is not, only because in all of the developer stakeholder group meetings that we've been having bi-weekly for a few months, it has never come up. And I know Wilmot services a portion of their municipality themselves. It would probably, it would require clarification from Wilmot or the region, but I want to say, just due to the fact that it hasn't come up, that it's not included in that.
Thanks. You make mention of the groups and the committees that have been put together, and I will applaud the region for one thing, which is making the tent big and allowing active participation from all the different organizations and associations. And I go back to the comment that you're by far the most brilliant water person I know. But having said that, you've forgotten more about water than a lot of elected officials and a lot of people on this call would. But it's nice to know that the science background is important. I think people need to understand that too. This is not an emotional decision that the region is making. This is a logical, math-based decision focused on both water consumption, water preservation, and ultimately the economic impact of this to our region, of which is getting bigger and bigger. The question is the Holden development for the whole region? There's a little bit of confusion in the public, because the record says one thing. There's so many rumors in this town. So is there any clarity? Is the hold for the development for the entire region?
No. So it is for the area that is serviced from that Mannheim integrated urban system. So which is uh, sort of centered around it's a large area. It's not the
Right.
entirety of the region. So the map I think is available on their website as
Hmm.
they have a page dedicated to this. I believe the the map is there. So
Okay, question. Is there an input versus output study as recovery from wastewater and recycling back into the recycled water back into the system? I'm assuming that's all part of a capture.
yeah, I know that the region has a whole separate group on conservation, which I think this would fall under. I'm not sure um, if that is factored in or how it's factored in. So unfortunately, Steve, I can't answer that one.
And then the comment, what area of Waterloo region does risk of low water levels? Is it just
Mhm.
Manheim? I think you've addressed that.
That's the only area that staff have flagged as the water level being at a critical level. I think generally water levels are trending down across the region, but that would be common across Ontario. It's water levels are dropping over the years, so that's not uncommon. But the critical area is around the Mannheim treatment area.
There's a comment here about call me crazy, but have there been conversations about reduction in demand? We can have some fun here and talk about
Yeah,
watering golf courses and watering lawns and things like let's not get let's not
yeah.
upset the minority population. But what impact would that have? I mean, that's a short term
Yeah.
process. But what are your thoughts on that?
Well, we've had discussions at the stakeholder groups about that. The problem is that in order for region staff to be comfortable that demand has decreased, they would want to actually see that. So if we were to say right now, everybody stop watering their lawns, that would be great. They would want to get through 2025 to see what impact that has on demand before they had a level of comfort to free up additional capacity. And I don't fault them for that. I'm sure they have an idea of what lawn watering, for example, uh, how much that impacts the overall consumption. But that's a hard one to bank on when you have no control over whether or not the people are going to water their lawns other than through bylaw. So yes and no, it's been looked at, but some of those things, fixing leaks is another one that's been mentioned. There is a not insignificant amount of what they call non-revenue water. So that's water that's just naturally lost through distribution system leaks. But again, the region would want to fix those leaks, see the reduction in average day demand before they could bank on that and release some additional capacity.
Yeah, it's an interesting situation that we live in with the governance model that we have,
Mhm.
where the Commissioner of Water, I believe, talked about leaks being just the realities of a system.
Yeah.
And then when the question was posed to the individual municipalities, they said, "We don't have any water leaks." Like it's
Yeah, yeah. I think I think they acknowledged, because I was at that meeting, they acknowledged some, but it was the commissioner didn't think that their estimates were sufficiently high enough. It is significant. I think most municipalities generally aim for um, loss through leaks as about 10%.
right.
Um, but I think in a lot of cases it's higher than that. But again, it's not a quick fix.
There's a comment here, and I think it's interesting. And I'm just going to paint the picture of Waterloo region. Great stuff. Has the region shown any openness to take your methodology feedback, which was their own back from 2025? So I guess this is where we're at right now. We're in
Yeah.
Waterloo region. If you haven't heard a rumor by noon, you start one. There's all kinds of speculation going on about what people are saying and what are they not saying. It's hard for anyone to commit to that. But
Mhm.
what kind of feedback or openness has there been to A, accepting this presentation, and B, going back to their own methodology?
We've had some discussions about going back to the methodology, and I want to say they're hesitant because they identify the problems with that previous methodology. I agree that the better method is to use what they're proposing going forward with the resiliency factor. Where we disagree is how you implement that. They are wanting to implement that now, which results in a massive deficit on paper. Um, I'm suggesting that be sort of their stretch goal, or their, something to achieve in X number of years, 5 years or whatever. As you get into a situation where you've hit that resiliency factor, that's the time that you switch to using that. The fact remains that they've got a water management philosophy that they adopted in 2015, which is the reserve supply capacity, adding 20% onto average day demand. And that's, in my opinion, what council at the time adopted. They haven't adopted the new method yet. And that's where I think council needs to decide to or confirm that they're operating under the 2015 method of calculation until there's a new method adopted.
So what we don't want to do is hang Chris out there. Say, okay, Chris, it's all yours. The question, and there's been a number of questions in the chat, and both from the Grand Valley, Water Region Home Builders, Conestoga Heavy, Cornerstone Realtors, Build Urban, is what should we be doing? So I'm maybe asking you to wear both hats here, both your engineering hat and ultimately your elected official hat. What is the voice? I mean, yelling and screaming, saying you're incompetent does not work. I get that, but this, the impact of the economic impact of this is significant, understanding the conservation. So what can we do as a group?
Well, I think it's difficult for staff and council, because council's relying on staff to provide their advice. Staff is providing advice that is like I just said, good advice, but there's this disconnect and difference of opinion on how you implement it. I think council needs to realize, and that's what I hope when I do the presentation next week, is that there are other ways to proceed in the interim. There's risk associated with it. Like
Sure.
using the old method, there is risk that you're going to start having some water supply shortages. But that risk can be managed, and they need to weigh. It's a political decision to weigh that risk versus the risk of shutting everything down. I believe CMHC said there were 2 housing starts in the city of Waterloo in the first quarter.
Yeah.
I think they need to weigh the risk of operating versus the economic risk. I'm not a banker. I assume when this gets cleared up, lenders aren't going to be rushing to Waterloo to start writing checks again until they see some certainty that there's not going to be another freeze. So I think they need to weigh those two things, and it's very much a political decision at this point. So staff is recommending something. It's up to the people around the table to decide what is the best for the region overall.
You were alluded to, is it the 20th you're presenting to council?
Yes. Yep.
Is that an open meeting or
I believe so, yeah.
And then there's
It's
another
at
date.
7 p.m.
7 p.m. There's another date, I believe June 3rd, where
Yeah, I'm not at that one.
Okay, so is it helpful to have people in the audience? I know the rules of decorum don't allow for signs and whistling and hooting and hollering, but I think are more people behind you in the horseshoe of value and the impact of this? Would that provide assistance?
Well, I don't think I don't think it hurts, and I've never had a supporting cast before. I don't know. I've got a big head to start with, and I don't. It might get too large, but I'd be happy to see people there. Like, it's a very important issue, so I think it warrants visibility from stakeholders such as everybody on this call.
Okay, Chris, we can't thank you enough for your participation again. Through Marie and the team at the Waterloo Home Builders, first of all, for hosting this, having access to participate at that lunch, gaining some inside information. It is math. It comes down to determining the methodology. We hope that the region does the right thing. I know what I believe the right thing is to be, but there's a number of people with different vested interests in this community doing so. We will amplify our concerns. As I said to everyone at the onset, this is being recorded and it's open for distribution. And I encourage people to look at it. I don't want to bombard you with thousands of emails, but if we filtered emails through us and if there was any points of clarification, would be okay if people sent the information through us. We'll summarize, frequently asked questions, get some standardized process and move it through and get this information up front. Again, it comes down to what is right, and
Mhm.
math is right. Let's determine the methodology, we hope. And hopefully we get, well, not hopefully, we need to get this region turned back on. So this is pretty interesting. So Chris, thank you for your time. We really appreciate it. Thanks for your knowledge and the information you put together. And with that, we'll end this and look forward to further conversation.
Okay. Well, thank you for having me. It was a pleasure.
Take care, Chris. Bye,
Bye-bye.
everyone.